Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with different aspects of mathematics, physics, chemistry and biology and other related topics. So in this case, we're going to look at the concept of functions. And in our earlier videos, we have done a few aspects of what we can be able to define as a function. And in this case, we're going to just have a quick recap of what we had discussed so that it can be able to assist us to pinpoint basically what the concept of a piecewise definition entails. So in this case, we have defined a function as a special type of relation, which of course we are given as a particular ratio, which is or rather a relationship that is going to consist of what we refer to as a special kind of a rule, which is going to assign each element in the domain to exactly one element in the range. And basically, we are given this specific two terms, whereby we talked about the domain and the range. So basically, we're going to just use an illustration in order to just give that specific concept of the domain and range. But in this sense, if we try to give perhaps an algebraic illustration of this, it's going to assist us in trying to define what basically, or visualize what we can basically refer to as a function. So in this case, I've said that a function is a special kind of, or rather it's a special type of a relation, whereby we're going to see that it can as well be defined as a special rule which assigns exactly one element in the domain to another element in the range. And of course, this is going to be given in terms of an equation which I've given on the board for us in order to remember. So in this case, if I try to look at this specific equation, we can be able to try and assign what we refer to as elements. And in this case, elements I'm going to refer to as numerical figures. They can be 1, 2. So this is going to perhaps range from this is a negative infinity for a range of values to positive infinity given as such. So therefore, I can either assign a negative or a positive value and try to see what are some of the outcomes of this specific case for the function. So in this case, I am going to consider this special type of relation in terms of two variables, and these are going to be variables over x and y, which are given as such. So this is going to consist of a variable, so the first variable 1 and variable 2 given as such. So these specific variables are going to give me a relationship, and I'm going to define these specific variables as the dependent variable, and the second one is going to be referred to as the independent variable. So this dependent portrays the aspect of dependency, and this one is going to be assuming a specific nature in which it's going to be, of course, having its own kind of characteristics. So therefore, this basically is going to depend on this, and this is why it's being referred to as a dependent variable. So for any change in this specific a range of values, it's going to dictate exactly what value is going to appear in this. And in this specific case, and therefore we can be able to say that for a function is going to consist of just a one value that is going to assign a specific value on the other side. So therefore, we can be able to assign this one in terms of a range and domain. And then it's going to be stated that for all the elements that are going to be contained in the independent variable are going to form a range of what we refer to as a domain. And all the elements that are going to be contained in the first variable with respect to y, and therefore are going to be referred to as a range. So therefore, this can assist us define a function whereby we're going to say that this special type of a relation is going to assign each element in the domain to exactly one element in the range, and that is going to give us our relationship. So in case if I try to give it in terms of a tabular form, I can be able to represent these elements for y and x, which are going to obey this equation, or rather give the values of this equation. So suppose I have, this is going to be the independent variable, so this is going to depend on this. So if I assign values for x is equivalent to 1, the value of y is going to be 2. So if x is equivalent to negative 1, then the value of y is going to be negative 2. So if x is equivalent to 0, then y is going to be equivalent to 0 as well. So this is going to dictate on what value is going to be assigned in this case. So therefore the independent variable is going to dictate on what value is going to be assigned in this specific case. So if we try to, of course, consider some more of this specific equation, we're going to see that some functions are not going to be defined by two, or some functions are not going to follow some rules that we have assigned in this specific case. Now, if we try to consider the function of, or rather the equation of y is equivalent to the root of x, we can be able to assign this one to be a range, the aspect of the range and the domain, and therefore we're going to say that if you try to look for the values of y and x in this case, we're going to consider and see whether each value in the domain is going to have a corresponding value of one corresponding value in the range in this specific case. So suppose I have x represented as 1. The root of 1 can either be positive or negative 1 given as such. And if x is going to be 4, the root of 4 is going to be represented as either positive or negative 2. So as I defined a function that is a special type of a relation that is going to assign each element in the domain to exactly one element in the range, I'm saying that it's going to assign 2 elements in the range for positive 1 and negative 1 respectively as such. So therefore we're going to consider this one from that specific statement to not falling under this specification for a function, and we're going to see how that one of course is going to affect our later discussion. So we can be able to denote a function as given as such. I've given an example of a y is equals to x. So we can be able to just have a general designation for a function, whereby we're going to assign it or give it in terms of y is equals f of x. So that is, of course, it's going to be read as y is a function of x. And of course, we're going to be specifying the value of y corresponding to x as such. So there are various functions which we can be able to define using this. And I'm not going to go in deeper details for those specific functions. So we're going to see that sometimes a function can be defined by 2 or more equations of a specific domain. So in this case, I've just specified just one equation in defining a function as y is equals to x. So suppose there's a function that is going to be defined using an additional, perhaps, of course, equation, just to give it as 3x plus 1. So suppose a function is defined, for instance, a function gx is defined using those 2 specific set of functions for y is equals to x and y is equals to 3x plus 1. Therefore, this calls for us for a different way of trying to define this specific function. And this is going to assist us finding the values of those specific values for the range of the domain and the range respectively. And this particular case, it's going to be accompanied by giving particular values for the range of those specific equations that I've given for equation 1 and 2. So therefore, that is going to be a different way in which we are going to define this specific concept of a function. So a piecewise defined function is a function that is defined by 2 or more equations of a specified domain. And therefore, from my particular example that I've given on the board, this can be given as a type of piecewise definition of a function, but it's going to lack one aspect of giving that specific range for the domain as I've given. So therefore, I can just give an elaborate example of what I can be able to refer to as a function. And for instance, now I can give this one the function f of x being represented by 2, of course, functions. That is x squared plus 2 all over x. And then there's another one which is going to be 2. So the function fx can be equivalent to x squared plus 2 over x, or just equivalent to fx is equivalent to 2 given as such. So in this particular case, of course, this is going to consist of the concept of a piecewise definition of a function, which is going to have two specific sets of a function in this case. So it can be either 2 or 3 or a number of them. But for this case, for us to define the first set of a function, we're going to put a condition whereby the value of the denominator is not going to be equivalent to 0. And of course, for this set of a function, we're going to give as well a domain for this whereby x can be equivalent to 0 for this second case. So in this case, we can be able to see that for a piecewise defined function, it's going to consist of 2 or more equations, and they are going to be given over specified domain as I've given for these two specific cases. So for piecewise defined functions, we're going to see that we can be able to solve these piecewise defined functions by trying to solve those specific equations with their respective ranges and trying to obey the condition which have been assigned in that specific case. So suppose I have one of the equations that I'm going to just write on the board. I can be able to give this one as the g of x as a piecewise defined function stretches between equations x is equals x minus 1, and then lastly we're going to have their specific ranges given as x is a set of values between the open negative infinity and 0. This is confined. I hope this is going to be. And then we're going to have x for the second part as a range of values or a set of values between the closed intervals of 0 and 4. And then we can be able to give the condition, the range for the last one as x as a set of values ranging between the closed interval for 4 and open for positive infinity given as such. So if we try to consider this one, the second case for g of x can be defined as a piecewise defined function, and therefore we're going to have this, of course, equations are given, or rather these statements or equations given in terms of x squared minus 1 is going to fall. The values of this for the range and domain are going to fall under this negative infinity and 0. And suppose we are requested to find the value of perhaps g when the value of x is equivalent to 2. So we're going to write this one as t into 2 given as such. So we're going to consider the three range of equations we have given in this particular case, and we're going to confine ourselves to a set of values of x which are going to have 2 as one of the set of those numbers. So if you try to look at this, then therefore we're going to see that for the first one, we're going to see that it's not going to obey that specific respect because the upper boundary is going to consist of what we refer to. So this is a closed interval. It's going to consist of what we refer to as negative infinity to 0. So positive 2 is a larger value. So therefore it's not going to be obeyed by the first equation. And then the second one, we're going to look at the value of gx, which is equivalent to x minus 1. And it stretches from the closed intervals of 0 to 4. And then therefore it can be able to fall under that category. Therefore, we can solve for g2x is equivalent to x minus 1, whereby we're going to see that we can do a substitution for this, and this is going to be equivalent to a value of 1. So therefore, we can be able to find for this. And then for the last one, we're going to see that if we try to put this condition of gx x equivalent to 2, this last equation for gx is equivalent to 3 falls under the set of values whereby x is a set of numbers from the closed intervals of 4 to positive infinity. So 4 is a large number, therefore it's not going to fall under this category. So that's how we're going to check against those specific ranges and solve for piecewise defined functions in that specific order. So I hope that this is comprehensive. So catch us in our next video where we're going to look at various applications of these piecewise defined functions, and they are going to assist us, of course, apart from other way of defining the normal functions in trying to solve some of the algebraic expressions and other related topics. So that is it for now, guys. Bye. God bless you.